sharp and the good stuff, like just whatever grades.
Alright, good to go.
Order this online. One was a free HDMI cable.
Ah, good.
You had a.
Good.
It does. It does.
Okay, you're on.
Anyway, you turn it.
Yeah.
Hit input on the other side, please.
Have system hospitals.
I mean, I actually still
downloading
free.
free.
Was affected by it.
HDMI
But
cord.
it's not
Or
free.
whatever. $10 HDMI cord.
Yes.
Yeah.
Unfortunately, I was just like that.
I haven't seen G Club since like
well,
2004. It was like the scene that just brought that man like, whoa.
Okay.
Remember those days? Bishop Price, first assistant.
All right, everyone. This talk is titled Get Flux. It's a talk written by Sean Moore under the Creative Commons Attribution Share Alike license. I believe that's the specific one that it's under. So that's why I have this notice on here. It's being presented by me, Dylan Hardison. I work with Sean, and I consider him a friend, and hopefully, if he ends up seeing the video of this, I don't butcher his talk too horribly.
Whoop. Alright. Good. Flux. Alright. Alright.
So, how many people here know about Git? Know what Git is? That's okay, some hands that didn't raise are actually questions. So who here doesn't know what Git is? Awesome. Who here knows what version control is? Okay. Have you ever used CBS?
No.
Have you ever used Subversion?
Yes.
No.
Okay, so version control, just briefly, I think I have trolls in the audience that are trying to just mess with my mind. Especially there. It's really hard looking at. I want to look at the light. I'm not going to head towards the light. I'm going to head towards the camera. Hopefully, this is
Right. Okay.
Version control is tracking the changes to files, simply. I'm not going to go into the philosophics of version control, but what you should know about Git, I guess, is that Git keeps track of changes to your files. Those of you that raised your hands that are sitting next to people that didn't raise their hands, you can explain to them after the talk. So what I'm talking about today is Git Flux. If any of you know the card game Flux, I'm a big fan of it. It's a very interesting card game. It has nothing to do with this talk other than the name. So before we dive into details, what this is about is a workflow of using Git, specifically how you use branches to manage your software development lifecycle. So it's based on I don't know if Sean's going to say it's based on, but I think it is on Git Flow. But Git Flow, I believe, is more complicated. And we have found that we didn't need that complexity. So this right here is Git Flow, which I'm not going to bother trying to explain, but it's pretty graphic. So Git Flux is based on some principles. These principles are that branches are for concurrent development. At my company, when we're working on projects, if we have more than one developer working on a project, frequently even if we don't, we manage different features in different branches. What a branch is, I guess I should digress since for the neophytes. Yes, Brian?
Can you give an example of different features?
Yes, actually, I'll use the same examples I used at the TAMP meeting, which went unrecorded. Okay, so for our example program, that instead of talking in hypotheticals, the projector just turned off. Someone just stepped on the projector cord. That's okay, I can live without the projector for the moment while it's fixed. So someone will need to hit the input button as well. My laptop should be perfectly happy. For our demonstration, not demonstration because I'm not going to actually show any code, but all of you here that have anything to do with software development should know what a hello world is. Our application is hello world. Pretend that our application is a hello world. A hello world is an executable program that outputs the string hello world. That is what you're starting out with and what you've just imported into version control. And then this is a contrite example, but it will serve our purpose as well. There are two features that we'll be going over and over again in the development of this. The first feature is a localization feature, which means that hello world can accept an argument and output its message in different language, assuming it has a translation for the string.
So English versus Martian.
English, French, Spanish, Japanese, we'll go with that. Was it bonjour? Buenos dias. I'm not going to try the Japanese. Sean was giving us, he speaks Japanese, so well. It's not actually his example. I forget the example he used. My example is really trite. So I'm going to assume there's also developers that will be working on a feature that is considered a bad feature, and now liked. The bad feature will be the developer that implements a feature, perhaps intentionally, perhaps unintentionally, that deletes all of the files from your hard drive. This will be the -R option. So you have I'm giving the names now, I took it previously. You have -L to specify the language of your hello world message, and you have the -R message, which deletes everything that it can from your home directory. If we cap in the current discussion of branch features, we require the third one. The third feature will be fixing a bug that was introduced because, actually the third feature will be implementing a function that sends out the hello world message as an email rather than to standard out. And you'll see the reason why I choose that feature in a second. So, getting back to the principle, the flux principles. So, does everyone understand what a branch is? I guess I didn't really explain what a branch is. A branch is separate. It is a separate version of all of the files in the repository. I'm simplifying how Git actually works, but I want to explain process, not details in this talk. So, a branch will be your set of files in the repository with a name. If you get down to the nitty-gritty of how Git deals with storing stuff, this is important. But it's not important for the discussion right now. So, oops, Dylan. Yes, Sam.
How are the files in your branch related to any other branch?
Okay, so I'm going to digress because of Sam's question and give the layman's explanation or my understanding of Git. Every file in a Git repository is represented by its content. So you take the file name, you don't care about the file name. You take everything that is the file, and that's what the file's name is. You actually use hashing, but that's not important. So the content of the file determines what its name is. A file is a blob object, and there are many different other types of objects. The other type of object is a tree, which references a blob. The file name of a file name. The name of a tree is the content of all of the things that it points to. A tree, a commit points to one or more trees, and a commit object is what a branch points to. So a branch is a name of a commit. So you can have two different branches which represent two different commits, and that's what a branch is.
So also different versions of those files.
Yeah, and a branch is changing. Every time you work on code and commit it, then what the branch is actually pointing to will change. So if I have a copy of, because Git is decentralized, if I have a copy of a Git checkout and you have a copy of a Git checkout, these two checkouts the names will be pointing to different hashes. So you'll know that they're different by looking at the content. This is actually how you do development because you send push or pull changes to and from the different nodes. This is more details than I really need to get to discuss the principle. So basically, a branch is a collection of stuff. So branches are used for concurrent development. That means every developer is working on their own copy of reality. Everyone's already has their own repository, but every feature you're working on exists in its own copy of all the history. The role we have is the master branch, which is the default branch in Git. It serves no special purpose other than it's the default name of the branch that you start out with when you have a fresh repository. But using Git Flux, we signify master as what is on production. Obviously, what's on production has some wiggle room depending on how your environment works. But if you are in a simple environment, production is the shipped package of the hello executable that someone's going to run. I left my contrived example. The third principle is that master is always releasable. That means that what's in master isn't broken. Master doesn't break. Master doesn't presumably delete all the files from your home directory. Branches are developed in isolation. What this means is if I'm working on the feature that does the translation for the output, and Sam is working on the feature that sends out the message as an email rather than printing it to the screen, we are working independently of each other. So he has his branch, which would be called email send, blah, and I will be working, the blah there should be a ticket number if you're going to go into that, but this is kind of orthogonal to the process. The fifth principle is that we use a release branch for integration. This will make sense when we get to the graphics. A release branch is a branch where all of the branches that people are working on come together and get worked on. Also, release is always rebuildable. What this means is that at any point we can decide to throw away the release branch and start over. So we're going to go step through an ideal release. Yes?
What happens if a branch which is developed in isolation breaks another branch that was developed?
That's a later slide. Stop getting ahead of yourself. We're going to cover the case of an ideal release. This is the chart that we will use for expressing Git differences. At the top of it is our markers that you'll see. Going down through the lines will be time, as going down represents time. This isn't temporal time. This is merely the time represented between things changing. So base is created off of master. Base serves as a copy of master that we use to create all of the release branches. We do not branch directly off of master, and it will become apparent why we do not do that right now. Base gets a version number, which will be the version that we're going to release. Release branches are created off of that. So the release branch, I should point out for those that are not familiar with Git, base and release at this point in time do not have a little dot on them because they are the same thing. There are two names. Actually, we have three names. They're all pointing to the same reference, to the same commit, to the same set of code.
To the same branch?
To the same branch. No, not the branch. A branch is merely a name. It's without meaning, really. A branch merely is a human. Branches are there for humans to be able to refer to them because you don't want to write a big, long hex string referencing a commit. So they're a convenience.
Gotcha.
We give them some meaning because, like, base is not just named base; it's named base with a version number in it. So here we have our first topic branch created and a commit in it. We will say that this little dot, this little yellow dot, is a commit that implements the multi-language feature of the Hello World contrived example. Green. It's actually green. Oh no, it's not. Green is base. So, but that still does not represent a different commit. At this point in time, blue and green should represent the same thing. Yellow represents the contrived email language, contrived language feature. And to release, as we would create a release branch for that feature, we would merge it into the release branch. So the release branch has now pulled a change from the topic branch. Meanwhile, time progresses. Is that actually? Hold on. Yes, Brian.
So,
I'm so incorrect. I'm going to back up a little bit. I misread my notes. Green is our first. I was correct. Green is our first commit. Dots do represent commits in all cases. Yellow represents the second feature, which is going to be deleting all of the files from your home directory. We merge to delete all your files in your home directory commit. More work is done because there was a typo in the language code, so it was not compiling, so your build server kicked it out, something like that. More development work is done. You merge into It's that. So both this line of development in yellow and this line of development in green are now represented in the release branch. Testing continues. You probably send that to QA. More work is done making a lot of typos and getting the language code thing right. Perhaps you're actually committing the translations themselves and you're making a lot of typos in the translations, or you're adding lots of translations. So development still continues. It gets merged. It's kind of hard to see on this. I can't even see it, and I don't know what the video is going to look like, but the slides for this are public, so it merges back into base. And it gets released to production.
So I got a question. What do you mean when you say a commit? What is a commit? A commit is when you've coded a piece of something and you've saved it. Is that considered a commit?
Hold on.
A commit's just a snapshot in time. So you
Yes.
make a change and you want to save that change.
So-
You commit it, and now that change has been saved in time as a snapshot. It's almost like if Dylan were walking across the room and you're taking photos of him, and you can always put Dylan back in the same position as at a certain photo shows him.
So
Gotcha.
foo.txt is a file that I've just created. File is now added, which you don't need to pay attention to that. That's I just committed a single thing in our history. There's one item of committing. If I were to change that file, so it says if I were to commit it again.
Gotcha. So commit is a snapshot.
Yeah, snapshot, basically. So, and then it can go back in time. So if you look at the thing, I think it's helpful to
Right.
see the thing, those big long hashes
Right. So
represent commit. And if you were actually to look at that, it points to a tree. The tree has one item in it, which is the hash of I forget. There was some way of listing the hash of the file, but I'm looking at it right now. So. So that was an ideal release. After this, we can delete all these branches. Yes, Sam? Yes, Brian?
Okay, so merge is where.
We're not discussing merges yet. This was an ideal release. The merges just happened. Both of these lines of code converged. So if you're looking at that, if you're looking at the history, these commit objects have two parents. They can, which is a two-way merge. I think that's right. The correct statement. Projector just moved. So they have two parents. They point to two different things. So you can still see these points in history. But when we do a release, we don't need to keep the topic branches around, or the release branch itself, or the base branch that it comes. Well, we need the base branch it comes from. But there's no real point because everything's been merged into release, and those names are really ephemeral at this point. You just keep master, and you'll go on about your life. So we delete them. But as Brian asked earlier, what happens if two features require interaction? Once again, time. We have our master, which is now at 1.1.0. We make a base, which is going to be named base 1.1.0. We make a release branch, release 1.1.0, and we start hacking. This is going to be the same process again, well, slightly. The green commit is implementing the language feature. Implementing the language feature, I'll say a bit. Now, there's an important change. And what this important change is in yellow, I'm going to have a contrite example for you, is if someone is working on the code that sends the hello world out as an email, and I'm also changing what the content of the hello world is from a localization table, this is going to result in conflict. And so we could keep developing these in isolation, and every time we merge into release, we're going to conflict. It's going to be, well, every time though, but anyway, it's going to be messy. And probably the person working on green wants to know about the email feature. So what happens is you pull it back in to base, you cut a release from that. Green's development continues. This time he pulls in because he knows they've communicated presumably that there's been changes in base, so he pulls in the changes, continues on. New branches get any changes made to base, so any third developer comes in, third feature comes in, you always branch from base. So you already have the new feature that's been shared. A release is cut again from here, and we continue on with the release. So it's been released. So once again, we delete the release branches, base branches, and we have all the history of that happening here. Yes, Brian.
What's the goal?
Yes. I don't know your name.
My name is Daniel.
Hi, Daniel.
What's your name?
Dylan.
Dylan. Good to meet you. I'm wondering if you have two forks, like if you had a system that got changed specifically for somebody else and you wanted fixes to go to both branches, are you going to get in that kind of thing?
No, we don't. Okay, so did you see the basic principles, or did you?
I didn't know the base principle.
Okay, yeah. So the line of that is, I'm actually in that situation. So what we've done, I think if I understand the situation correctly, we have multiple concurrent versions of the same product that are maintained differently with different patches. And,
Right. But
so we number everything. So in this particular case, these multiple different versions of the same product are based on years. So we've been affixing the year to the name. So we have a 2014 master, 2013 master, 2012 master.
Okay.
And then all of the branches based on that is a 2012 base, 2012 release, and then still the version number after it. So, and if we need to apply things across them, this is sort of outside of the get flow thing. We just merge the branches together, because you can always merge branches,
Right.
unless they've gotten too divergent. Hmm?
So you could also just simply do a pull request, one for the other.
Well, I mean, you don't have to do a pull request if you're the same developer
What
working
was
on it,
the-
or you have right access to the repository.
What was the actual question?
Like you have,
If you have multiple-
He said it's outside of it, but it's like if you have a program and then you made another release for somebody else, but you want to add new features to both of them, but you don't want to.
I kind of sounds like you're getting to the next thing. This kind of sounds like a mid-cycle hotfix, which is actually a thing that.
That sounds good right then.
Okay, so you'll like the next step.
All right.
Mid-cycle hotfix. Time, development, we're now at 1.2.0. We create the base, release, topic branches. First topic branch, same email feature. But I'm pointing out that I'm trying to go through the same thing, so I'm always talking about the same features being implemented because it's easier on my brain and they're mildly amusing. So this time that's the email change, or not the email change, that's